Hi, everybody. My name is Joe Fish Kay. I am Principal Research Scientist in the Emerging Technologies Organization, and it is my pleasure today to introduce you to Kathy Reid. This is part of an ongoing series that we have within ET, in which we try and get people from the larger world to talk to Mozilla about issues that are relevant to us, and to talk about how we can have that relationship with academia, right, and where we're seeing people working on things. And I'm particularly delighted to have Kathy, because she's taking this analytical approach to thinking about open source, and particularly a category of open source that I think of as data-driven open source. I have wanted for a long time to think about modifying a world to talk to Mozilla about issues that are relevant to us. Sorry, I'm talk about how we can have that relationship. Some idiot was talking on Hubs, which is me. Sorry about that. I've wanted for a long time to have someone to come in and talk about our relationship to data, right? Because what I think is particularly exciting about the work that Kathy will be presenting today is that she is doing a very looking at a very data-driven approach to open source work. And I think if you look at Article 6 of the manifesto, Article 6 basically says, look, Mozilla is a big fan of open source code. And I would love to see us, next time we go and revise the manifesto, I would love to see us say, look, we're a big fan of open source code and data, because the ways that knowledge is created in the world are changing. And the ways that open source is creating knowledge in the world are changing, and they're changing in this data-driven way. I was really excited to see that email that came out the other day, in that we've now got a VP of data coming and joining us, I think starting next Monday, the Monday after that. And that's the sort of change that I think we at Mozilla need to take seriously, is understanding the role of data in creating open source experiences, but still taking seriously what it means to think about privacy and what it means to think about taking these things as first-class parts of the open source ecosystem. So I'm going to stop rattling on, and I would like to introduce you to Kathy Reid from Australian National University. Over to you, Kathy. Thank you.
Thanks so much, Joe. Thanks so much, Joe Fish, for that lovely introduction, and also for the opportunity to chat with everyone today. There are three things that I'd like to do before I start the talk proper today. Firstly, I'd like to acknowledge that I'm presenting today from Canberra in Australia. This is the land of the Ngunnawal and Ngambri people, the Indigenous traditional custodians of the land, and I pay my respects to their elders, past and present, and to their leaders emerging, and I especially welcome any Indigenous and First Nations people joining us today. Secondly, I'd like to acknowledge that much of the open source voice ecosystem is built on the efforts of those who have volunteered, in the words of Tiffany Ferris, their time, talents, and treasure, and I'd like to take the opportunity to acknowledge their contributions now. Thirdly, and I think for many of us most importantly at the moment, I recognise that this is a very trying time for people all over the world dealing with the impacts of COVID-19, and I sincerely hope you and your loved ones remain safe and healthy. So who am I? As Joe Fish mentioned, I'm Kathy Reid, and I have a strong background in open source and some exposure to voice through my time at Mycroft AI. Last year, I was one of 16 students from across the world who headed to Canberra to undertake an educational experiment with distinguished Professor Genevieve Bell at the 3A Institute. During that year, we were treated to a range of incredibly diverse, rich, challenging, and immersive educational experiences that had a single goal: to give us the skills to take cyber-physical systems, data, artificial intelligence, and machine learning reliably, safely, and sustainably to scale. And as a core part of that course, we were required to undertake a capstone unit that explored a key topic, and I chose open source voice. But today's talk isn't just for voice people. If you have an interest in how open source landscapes shift, or in how technology goes to scale, how it matures, how it evolves, and the trajectories through which this happens, then you'll get something out of this talk. I'm going to do a brief introduction to the components of the voice stack because I think it's useful to have an understanding of the different types of functionality that exist in voice, because it helps us to see how the landscape might be changing in a particular layer. I'll cover some open source assessment frameworks, and I'll be talking about why they're no longer appropriate as we enter an age of data, machine learning, artificial intelligence, and systems of systems. Then I'll be painting a picture of 3 waves of open source voice and some of the characteristics of those waves, and argue that we're on the cusp of the 3rd wave of open source voice, and that we have a rare moment to help shape the voice ecosystem over the next few years. So let's start with a brief intro to the voice stack. For those in the audience who don't have a background in voice, I'd just like to quickly deconstruct what's in the voice stack and provide an overview of the sorts of functionality that you would find in, say, a voice assistant. So most voice assistants use some form of this stack. So if you've used a web stack or an application stack with different components, this is very, very similar. We just use different software in the stack. Usually when we talk about the voice stack, we don't include transcription as a layer, but I've chosen to include it here for 2 reasons. Firstly, in order to train speech-to-text models, we need recorded audio and a matching written transcription and orthographic transcription. In many languages, there aren't a lot of transcriptions of recorded audio, so it makes it more difficult to train speech models. Excuse me. We often call these languages low resource languages because there aren't a lot of digitized resources available in those languages. Secondly, as part of this work, I've been speaking with several linguists at the Centre of Excellence for Dynamic Languages here in Australia. And for them, transcription is the key bottleneck that they have in their research ops tool chain. Transcription has a 40-to-1 ratio. That is, it takes 40 minutes of labour to transcribe 1 minute of audio. It's slow and it's painstaking, and we need to consider it part of the overall voice stack. Thinking about wake words, most people here will have heard of a wake word. That's the word that you say to wake up an assistant, like Alexa or OK Google or Hey Mycroft. The wake word software, called a listener, does just that. It is constantly listening for the wake word, and it's trained to hear the wake word. If we go down another layer in speech to text, this is the layer of the stack that takes recorded speech, audio, and turns it into written form, called an utterance. You might have seen videos with automatic speech captioning tools, and these use speech to text. Going down another layer, the intent parser takes the text that's generated by speech to text and tries to ascribe meaning to it. There are different ways of parsing intent, but a common approach is called slot matching, where the intent parser expects the utterance to have a particular structure that words slot into, like, please add a calendar entry for Monday at 5 p.m. where I do a thing. In text-to-speech, it's the opposite of speech to text. The text-to-speech layer takes written information and then uses a synthesized voice to play it back using audio. So if you have a screen reader extension on your browser that reads content out to you, that's text-to-speech. The voice assistant itself, Jasper or Raspberry or Mycroft, is like the glue that holds all these components of the stack together. It's like a wrapper or ribbon around all the layers in the stack. So it's a very brief overview of a voice stack and the different types of software that you might find in one. And so turning to what's special about an open source voice stack. Many of you will have used proprietary voice assistants. For context, it's estimated that by 2023, there will be 8 billion voice assistants deployed. And in 2019 alone, nearly 147 million voice assistants were shipped worldwide. Market share in this space, as you can see here, is hotly contested by Amazon, Google, Apple, and Chinese contenders such as Baidu and Xiaomi. Each of these companies has an overarchingly commercial imperative to turn voice assistants and the data they collect into profit. The business models used to do this vary, but by having an always-on microphone in your house, perhaps your bedroom, proprietary-based companies are able to gather significant data about you, your family, and your habits. And because it's proprietary technology, consumers and users of the technology have very little ability to deconstruct, inspect, and interrogate what's going on in this assemblage of technologies that make up a voice assistant ecosystem. Commercial drivers also mean that some cohorts are not serviced at all, such as those people who don't speak a mainstream language. For example, some of the big companies only just started to support the Hindi language, which is spoken by millions of people in India. And some cohorts are not serviced at all, such as those people who, and some cohorts are underserviced because the technology doesn't recognize their voice well, like women, some of whom have Australian accents, women, children, people, and people with speech impediments. These concerns over privacy, openness, equity, equality, interrogability, coupled with advances in technology that support machine learning, have seen a growing interest in open source alternatives to big voice. But how do you compare these open source products? What characteristics are important? Which open source products best lend themselves to the needs of different cohorts? So, I set about trying to answer some of these questions. And what I'd originally planned to do with this project was to identify or create an assessment framework for open source software, and then apply that to some of the software that's available at each level of the voice stack to see how it compares, give it a rating, and basically check the box. It sounds really simple and straightforward and logical, doesn't it? So you know how this story goes, right? Originally, what I'd had in mind was building or using a maturity model. You may have come across maturity models in the work that you do, but in case you haven't, I'll quickly cover them now. Maturity models typically look something like this. They're sequential, and the general idea is that you start in an ad hoc way, and then you improve linearly, incrementally over time, passing through stages of growth, like you would from, say, adolescence to adulthood. Many of the open source maturity models and assessment frameworks have taken exactly this approach, identifying criteria, then rating software along a continuum, a linear pathway. You know, does this software do X? Tick. How well does this software do X? 2 ticks. Many of the open source maturity models have the same starting point, the ISO IEC 9126 software standard. And this has in it exactly what you'd expect to find in a software standard. It talks about terms like functional suitability, performance efficiency, compatibility, usability, reliability, security, maintainability, portability. I'll stop there because I'll sound like a drone. What it misses is that all of the open source assessment frameworks have not been adopted in practice. So whereas ISO IEC 9126 has been adopted in the software industry, its adaptation to open source hasn't been widely adopted at all. And there's a couple of reasons for this. Firstly, it's really complex. It's hard to understand and it's hard to communicate. And there's also very limited tooling to support the automation of these sorts of things. So in order to do a maturity assessment, you have to do a lot of manual work to get some answers, and that's not particularly appealing. The other reason that these sorts of what I call traditional approaches haven't taken off in open source is that they neglect one of the main assets that we have in open source, which is our community. and only later attempts at open source maturity models have tried to take into account the open source community. And more importantly, none of these models take into account considerations necessary for an era of data and machine learning, such as things like the fair guiding principles for data. Is data findable, accessible, interoperable, reusable? These frameworks don't take into account things like bias in data sets, like gender bias or racial bias or ethnographic bias. And they don't think about the needs of under-resourced languages or underrepresented groups. They don't think about concepts like equity, which in a data-based world, in a data-driven world, are increasingly important. So I attempted to build an open source assessment framework that extended some of these existing ones by adding on measures for things like bias and how well the software supported additional languages. But I quickly realized I was making the problem worse. Voice doesn't fit neatly into linear ways of thinking about maturity. For example, is it better to have on-device processing or offload it to a cloud? Well, it depends. And linear maturity models don't deal well with that sort of ambiguity. Instead, as I read more about open source voice and voice in general, I started to observe some patterns. And that pattern can best be described as 3 waves. Each wave has particular characteristics, just like a maturity model does, except that it's not as finite, it's not as clear-cut. It's much more of a landscape with contours rather than clear-cut boundaries. My argument is that open source software, open source voice software, can be categorized into one of these 3 waves based on some common characteristics. Further, I argued that we are late into the 2nd wave of open source voice and on the cusp of the 3rd. We have a rare opportunity, an inflection point, to shape how 3rd wave evolves and what the future of open source voice looks like over the foreseeable future. We have deliberate choices to make that will affect voice technology. So let's take a look at these waves. So although voice technologies like speech recognition and speech synthesis had their origins decades earlier with people like Homer Dudley of Bell Labs and his proposal in the 1930s for speech recognition and synthesis, all the development here happened primarily within large companies. DARPA, Bell Labs, the Macy conferences of the 1940s and 1950s held the development of human-like speech as a goal. But it wasn't until another technical evolution, another trajectory intersected with voice, that we start to see the development of open source voice. And of course, that's with the birth of the free software and open source movement in the 1980s and 1990s. That movement found significant adoption in universities, and unsurprisingly, that's where we see the 1st wave of open source originate. This software was primarily used for research purposes and was the basis of several publications around speech recognition and speech synthesis. And tools such as CMU Sphinx and Caldi fit into this category, Mary TTS and eSpeak as well. These products often use rule-based inference for tasks such as speech recognition and voice synthesis. And they tend to use older or less popular programming languages. For example, the eSpeak NG text-to-speech engine still uses ANSI C, even though it's a very active project. And it's rare to see those languages used with more modern projects. So thinking about the markers for the end of the 1st wave as a whole, what I started to see when I looked at some of these software projects across the stack was that several of the research-based projects have been abandoned. And I dug into that a little bit deeper and found two causes. One is that the funding for the project dries up and it can no longer sustain the researchers actively working on it. But the other cause that's been observed, for example, in the case of CMU Sphinx, is that the authors have gone to work in the artificial intelligence sector, where their machine learning skills are highly valued. And so they've been taken out of the public sector, the research sector, and attracted into the commercial and private sector because their skills are so good. We also see at the end of the first wave the rise of developments in the hardware space. So we see in the 2000s the emergence of powerful GPU hardware. And instead of rule-based inference, we see the adoption of neural network-based approaches to machine learning tasks. So that for me is the first sort of shift in evolution, the end of the first wave and the start of the second wave. The second wave is characterized by software created by profit companies using an open source license as part of their business strategy, usually to attract large open source communities who contribute to their product offerings. And companies like Rasa and Mycroft are part of that. If you want to talk to me about SNPs, I'm very happy to do that after the talk. These products tend to use different types of neural networks for tasks such as speech recognition, intent parsing, and voice synthesis. So the way that they do what they do has changed as well. Where research is happening has also shifted. Instead of research being done by public universities and then published into a space where people can learn from that, what we're seeing is that research is being done by big voice companies rather than by publicly funded research institutions. A lot of that research is still published, but it doesn't have the same driver. It doesn't have the same origin. The research agenda is now very much commercially driven, not necessarily publicly driven. And my argument is that we're well into this second wave and we're on the cusp of a third wave. There are several markers that signify the end of the second wave and the beginning of a third wave of open source voice. We're seeing the increased proliferation of voice data sets across the world from which speech models can be trained. Recording and transcription are becoming easier. They're still not easy, but they're easier. And so it's easier to generate speech corpora for training. We're seeing the line between human and synthetic voices blurring. So Google is doing this in the proprietary space with Duplex, but we're also getting close in the open source space with the various Tachytron implementations for TTS that are around now. But perhaps the biggest marker here is that voice is going feral, in the words of Genevieve Bell. It's being embedded in smart speakers, in mobile devices, in cars, in appliances, and in smart home devices. We're seeing embedded electronics like Raspberry Pis used for all sorts of things that we couldn't have imagined even 5 years ago. Voice is going to scale as a component in cyber-physical systems all over the world. Open source voice is at a tipping point, an inflection point. The third wave of open source voice is almost upon us, and we have only a short window in which to exert some influence on that landscape as it unfolds. What directions can it go in? How do we shape those directions? And how do we make sure that we're building a world of open voice that we want to see? Let's look at some of those possible trajectories. And let's take a look at gender first, because, well, I'm an Australian woman and I'm tired of speech recognition not recognising my gender or my accent. So this is a piece by Madeline Morley that came out only last week, and she poses the question, what would a feminist Alexa sound like? And I think that's a very, very interesting question to unpack a little bit more. So at the moment, women's voices are not recognised very well by speech to text because the training sets on which they're trained, the data on which they're trained, doesn't contain as many samples of women. Women's voices are associated with subservient or system-based roles, and often voice assistants that sound like women will be harassed. And that harassment is left unchecked. The personas that these voices use will often adopt a very subservient or docile approach. I don't know about you, but that's not a trajectory that I would like to see continue into the future. I think we can do better. And so what does breaking out of this trajectory look like? I think what we need to focus on, as Joe Fish pointed out very early in this talk, is about the data. Voice is data-driven, and we need to think critically about how we use that data, how it goes through a value chain, how it's transformed into machine learning models and into services based on those models. So we need to be thinking about things like equal representation of female voices in training data sets. And I know for a lot of the open SLR resources, there was a paper done where they looked at whether there was equivalence in those data sets. And in the open source space, it's about a 2/3 majority at the moment in some of those open data sets. We have, so that means that there are 2 samples of male sounding voices to every 1 female sounding voice. So we need to think critically about that and how we have more equitable representation. We also need to design voice user interfaces and interaction in a way where the voices of women stand up to harassment. They don't just accept some of the utterances that are made. That's handled in a much more nuanced way. And one of the other pieces that came out as I was looking at the open source voice space is that we use different voices in different settings. So women's voices are often used in assistant type roles in voice. We give women orders, we ask them to do tasks for us. But men's voices are used in more authoritative settings. So men's voices are used where they're telling us about a product, or they're instructing us about a particular choice that we need to make. And I'd like to see us think critically about how we use voice data and in what settings we use that so that we're not inculcating some of these stereotypes and trajectories. There's a through line here too to race. Race is another very important trajectory. This piece came out only this week in the New York Times, and it talks about a paper that came out of Stanford where basically what the research paper did was assess how well people from different demographics were recognised within the speech recognition, the speech-to-text layer. And if you come from a predominantly white area, then your chance of being recognised by a voice assistant is much higher. And again, this is a data problem. Minority dialects, which often intersect along racial lines, are not well recognised in STT, speech-to-text, and they're less represented in text-to-speech data sets as well. Again, this is a data problem. We're not thinking critically about equity in data. We're not thinking critically about representation in data. So to alter that trajectory, to shape the course of open source voice over the next few years, we need to again be thinking about more equitable representation. We need to be thinking about the ability to give people a voice that they resonate with, a voice that sounds like them. Although at the moment with my Australian accent and stuffy nose, I'm not sure that I want a voice that sounds like me. Again, we also need to be thinking about positioning. and not using voices in a way that are seen as gimmicks. And I'm sure some of you in the late 90s and 2000s will have used GPSs with voices like Yoda or James L. Jones. So again, we need to be thinking about the positioning of voice. Excuse me, just one moment. Another very closely related trajectory is that of low resource, indigenous, endangered, and sleeping languages. And as a small aside, in Australian Indigenous languages, we deliberately try to use the word sleeping language rather than dead language, because if we use the word sleeping, then it offers us a space to think about how that language might be woken up again, how it might be reanimated and brought back. And there's a lot of work going on at the moment to think about how we reanimate some of our sleeping Indigenous languages. So this is Opie the robot, and Opie is helping preserve languages in the north of Australia at the Nukur Language Centre in the Northern Territory. And this is just one example of how open source voice and low resource languages intersect. So the trajectory that we're on here, again, is data driven. It's all about the data. Transcription is hard. So it's hard to gather orthographic material, written material, to support the development of low resource language corpora. And fewer resources mean it's harder to train speech models. There's another trajectory piece here as well that makes it harder for low resource languages to get a foothold in voice technology. And that's that often they have very small bases of speakers. So that means that low resource languages tend to be unattractive commercially. We've only just seen Hindi support in some of the proprietary voice assistants, even though there are millions of speakers of Hindi across the world. I imagine that the business case for a language like Warlpiri or Yolngu Matha, Indigenous Australian languages, is very hard to make. And I understand that. If we think about, again, how we might change or shape or change the pathway here, I think what we need here is stronger government support for the development of these resources, the tooling and corpora. And there's an echo here to the CODAL model in Australia, the Centre for Excellence in Dynamic Languages. The investment that they make helps to make voice and investment in voice in these low resource languages more commercially attractive. For example, the New Zealand government, which has Te Reo Maori as an official language of New Zealand, spends tens of millions of New Zealand dollars every year trying to build up resources in Te Reo. And I think that's something as open source practitioners we need to become more involved in, because it helps to both support those low resource languages, but support the ecosystem as a whole. There's another piece here about low resource languages, and that's by having an entire open source tool chain. The development of corpora becomes easier, the training of corpora becomes easier, and then suddenly we have speech models available in those languages. So we also need to think about the entire open source tool chain, the open source voice tool chain as a whole. Where are the gaps in that tool chain? So at the moment, we really only have Alarm for transcription, and the Centre for Excellence in Dynamic Languages is working on tools like ELPIS and Persephone that help to transcribe low resource languages so that you can train models to help you transcribe off very, very small data sets. Again, it's all about the data. Did I mention data? So we have a continuing trajectory here of poor awareness of the nuances of data provenance, of licensing. The person behind the data often gets lost. Current approaches to data are often ad hoc. The driver is to have bigger, more data sets, not necessarily better data sets, which might be smaller. And so to break out of this trajectory, we need some whole of life cycle thinking about data and where it fits into the voice value chain. And there's also an excellent paper that's come out recently from the Bennett Institute at Cambridge University. We've probably heard the mantra that data is an asset, it's the new oil, it's the fuel of cyber physical systems and machine learning. This paper reframes data and holds that it's a shared common good. Data is a public good. And just like our parks or just like our environment, there's a moral obligation there to make sure that we're treating public data that is a public good, in the same way that we might care for and have some custodial obligations around other public and commons resources. So we need to think critically about data as a trajectory. And metadata is also a part of that conversation. At the moment, metadata standards around open voice data sets continue to be patchy. There isn't an emerging industry standard yet. And to break out of that trajectory, we need to adopt a common metadata standard for labeling open voice data sets, gender, provenance, other markers that help to ensure representation and help to ensure that we have a much more equitable open voice landscape. I've mentioned before the role of government in low resource languages, but I want to draw some other touch points here as well. If we step back a slide or two and remember that the first wave of open source voice came from universities, it was research driven, and that the second wave was driven by companies who had open source voice as part of their business model, then we have to ask the question, what is the role of government in voice? Right now, governments have very little involvement, and instead of looking at open source options, they'll often use commercial voice providers for emerging technology experiments, particularly in the health sector. So there's some scope here for governments to have influence on how open source voice evolves. For example, by partnering with research organisations and open source voice companies to deliver value in areas that are not commercially viable by themselves. So think again of Indigenous and endangered and low resource languages. But we also have to think about privacy. For example, governments are responsible for regulation and for data privacy legislation. So I know in America, the California Data Privacy Act has just taken off, and America has the HIPAA regulations around health and private information. Germany and Europe has the GDPR. Here in Australia, we have some reasonable privacy legislation through our Privacy Act. What is government doing in the voice space to help ensure privacy, particularly in areas where personal information, private information might be disclosed, like the healthcare setting? So there's a huge scope here for governments to have influence and to be involved in how this trajectory shapes out over time. Governments also have a role to play in standards. So in many areas of government procurement, there are particular standards or frameworks that you have to adopt in order to be involved in government procurement. For example, in the UK, a lot of providers have to be certified in the ITIL IT management framework. In America, I think being certified in something like COBIT is much more likely. In voice and in open source voice, we don't yet have standards. So it's difficult for government to know how to go about procuring voice because they don't necessarily have a framework to assess voice or to think about yet. That takes me to standards and interoperability. So at the moment, we generally have poor support in the open source space for some existing voice standards like the speech synthesis markup standard. And at the moment, I would say that we have poor progress towards standards in voice and standards in open source voice. And that has a knock-on effect, that it's harder for open voice to be adopted by integrators. It makes it less attractive because you have to do things differently for every sort of open source piece of software that you touch. So it becomes less attractive for integration. Imagine that you're a voice skill developer and you're trying to develop a skill to do something in your smart home or to integrate with a particular API. Just like with the mobile space at the moment, where you probably have to make 2 versions of a mobile app, one for Android and one for iOS. At the moment, if you wanted to reach most of the market, you would just have to write a skill for the big 2 voice companies. If we don't have some standards in the open source space, in the open source voice space, we're not going to be able to attract skill developers because they're going to be developing skills for so many different platforms. So we need to think more critically about how do we make it easier for those developers to add value to that ecosystem. So I think in breaking out of the trajectory that we're on here, we need to think about how we have some standards and interoperability. And so I know that John Stein in the Open Voice Network is doing some work here. And I think that's something that we'll need to continue and have some more momentum. We also need to think critically about licensing, and there's a through line here to data as well. So the licenses that we use in open source at the moment are designed around software projects and products, but they're not designed around data. So how does Apache 2 or the GPL work for data, or for models that are the output of machine learning, where they might be an aggregate or a composite of the data from tens of thousands of people? So we need to have some more sophisticated thinking about the licensing of data, particularly where that data is an aggregate data set, such as STT corpora. So again, we really need to think critically about data. We also need to think about people. So at the moment in open source voice, there's huge competition for ML and AI talent. And that's often, that's making it difficult for open source voice to build and to sustain communities. Companies also treat open source communities differently. They use open source communities in different ways. And I'm not sure all of these are particularly positive ways. So for anyone out there who might have used Snips, you invested in a platform that you thought was open source, and then when the company was bought out, suddenly overnight, your investment in that, the work that you've done, is just completely devalued. So I think we need to think about how we approach open source communities with voice. And to break out of this, I think we're going to see more involvement of open voice at the university and college level, which has traditionally been a hotbed for open source projects. But the through line here that I think we also need to think about is how do we grow involvement in the community from underrepresented groups? And if we invest in low resource languages and in tooling for low resource languages and open voice, we're going to be able to grow the community from those underrepresented areas. It won't just be Europe and America anymore. So each of these trajectories is not likely to be standalone. It's likely that the future will be a little bit of each. For example, better metadata standards around voice data sets are likely to help increase the representation of women and minority groups. But those metadata standards won't be adopted unless there are some incentives for doing so, such as tie-in to government procurement regulations. The involvement of governments in open source are likely to assist with an increase in the availability of low resource language resources, which in turn helps to attract new community members to open source projects. So there's a lot of causal loops happening here. but none of these trajectories are inevitable or incidental. We have the power to shape the future of open source voice over the next 5 years, but we must act soon before the trajectories that are already in play are locked in place, and we cannot escape them. Thank you.
I realized that I was pausing there for the applause, right? Because when people say that, you're like, oh, well, that was a really good talk. And then I was like, wait, I'm not going to hear the applause. It doesn't work like that. Kathy, thank you very much. Take the applause from me as sort of, filtered through the rest of the internet. I have a couple of questions, some from me, some from other people, and I would love your thoughts on these. The first one is about the open source voice stack. I was glad to see your diagram of the open source voice stack. I'm delighted because I often find I use a diagram of the open source voice stack, and yours and my diagrams intersect in some places and not in some others. But the structure is sort of clear. And the thing that's interesting about that is, of course, there is a stack, right? There's a sequence of things that are depending on each other. Where are you seeing the fragility in that stack, right? And how are you measuring that fragility? And I suppose the question that I have that's sort of crying out to be a research question, maybe I'll put in this list of questions we're going to be funding through the Mozilla research grants, is how do you measure the fragility of a layer of the voice interface? And which are the ones that need the most attention? And in particular, which are the ones that Mozilla, as a company that is concerned about the health of the open source voice ecosystem, where should we be investing our effort and time, and how do you measure that? Nice, easy softball question to begin.
Oh, nice, easy one to start with. Look, I think to answer that question, I'd like to unpack what fragility means a little bit. I think from an open source perspective, fragility for me are things like the abandonment of projects. It's often when we talk about stacks in open voice, I talk about decks of cards layered on top of each other. So for example, at the moment, the CNU Sphinx project, which has been a mainstay of the STT layer and the wake word layer with its child project Pocket Sphinx, that's now all but abandoned. So projects that are built around CMU Sphinx are not going to get the updates that they need. So that's one element of fragility. How stable, how sustainable is that stack? At the moment, we're seeing a lot of work in the STT layers. We're seeing a lot of work in the TTS layers. But for me, the issue that I have is that the intent layer isn't very well, or is not perhaps as robust as it could be at the moment. We have some second wave open source voice pieces in the intent layer. So RASA, for example, has done a lot of work around intent parsing, but we also have open source projects like NLTK, the Python project, that do very strong intent parsing as well. The problem that we have with intent parsing at the moment is that we don't have standards around how intents are handled. For example, if I ask a proprietary voice assistant, can you please show me a price for a particular keyboard? There are all of the threads that go into that response are a function of what is the profit motive behind that commercial company. In an open source space, we don't have very good ways at the moment for disambiguating intents in the smart home space. So, for example, if I say, could you play something for me? We don't know, for example, whether that's a music request. Is it a news request? Is it a media request? So again, we see the through line here to standards and to making sure that when we talk about intents, we're able to have some continuity across platforms. So for me, fragility is that house of cards and components being so dependent on each other without having good standards.
I think that's a really good response, and talks to some very important issues. And I look forward to talking about that question with you more. I have a question from Felix Lawrence, who I feel is in the wilds of British Columbia somewhere, but it could be Toronto more, I forget. Sorry about that. An underlying factor that is leading to minorities being shortchanged is that optimizing a product for each minority takes additional investment, often out of proportion to the number of people in that minority. And how do we break that out? Do we legally require equal investment for each in a whitelisted set of minorities? Do we take a common voice approach in which communities themselves are empowered to support minorities they care about? And I will point out that the definition of minority is, of course, a locally constructed thing, right? The idea of what is a minority in the United States continues to surprise me. After living in the States for 20 years, I still get confused by what the assumptions are around minority and majority. And it pushes the question of, like, is this worth my effort? Does that process just push the is this worth my effort judgment from the companies and to the community? And does that make it okay or better?
That's a great question, Felix, and thank you. I think it's an excellent question and something we should be giving more thought to. This is difficult. And the way that I'd like to answer it is that as an open source person, I think we should be giving as many opportunities as possible for different parts of that sector to respond in the way that best meets their needs. So I've spoken a bit about how I think governments need to have more involvement, particularly in programs that are designed to provide resources for minorities. So in Australia, that might be resources for Indigenous languages, and we've got several hundred of them. In New Zealand, that might be for Te Reo Māori, and in Canada, that might be for Nunavut and Indigenous populations there. So giving government the ability to have some of these tools is one area to address that. The second area to address that I see is being able to have end-to-end stacks. So at the moment, the open source ecosystem is quite fragmented. We have software at the different layers of the stack, but it's very hard to bring all of that together. And so if you're a practitioner in a minority community, it's very hard for you to work with those stacks. So if we make it easier, if we make end-to-end open source voice easier for people, then we reduce the labor and we reduce the effort that's required to deliver an outcome there. So I think we need to be thinking about how do we reduce the effort that's required, because then it becomes more attractive as well. I also think that this also comes back to some human rights thinking as well. And this is driving some of the conversation around data and data privacy. We do need to be thinking about what it means to treat majority and minority data sets in equal and equitable ways. If a voice assistant can't understand me because I'm a woman, that's a human rights issue. It's a gendered human rights issue. If a voice assistant can't understand me because I'm Australian and I elongate my vowel sounds like this, that becomes a racial question. And if a voice assistant can't understand me because the language models there aren't there for the Indigenous or the endangered language that I speak, it becomes a human rights issue. So I think it's an incredibly important question, and I think there are multiple ways to have some influence over that. Thank you, Felix, for the question.
Yeah, that is not an easy question at all, and I continue to struggle with that, particularly as someone who's got a very strange accent from not fitting any of those categories very well, right? Like, I grew up in a lot of different countries as a kid, and I think my accent is some strange reflection of that. And I will say that voice assistants understand me not very well. To be honest, people don't understand me very well. I've developed a technique in the United States of when I am in a restaurant and I want to have more to drink, I'll ask for more water, because if I say water, no one understands like a word I say. I've learned this the hard way. I have another question, which is, and this one is sort of a kind of a detail, or you're defining these three waves of open source. And if I was to read your, if I was looking at the slides and listening to what you said, I think you're sort of talking about these three waves being approximately sort of open source in universities, open source in business, and open source in the world. And I can see sort of taking a data-driven approach, which would frame it a little bit more that open source wave one is these sort of handcrafted rules. Today, open source 2 is this sort of deep learning, data-driven, deep neural networks. And then what the characteristic of the third wave is this being deliberate about the data that's being used to inform these processes. Am I getting at the same things? Are these two different approaches on the same thing? Or like is there an underlying sort of deep truth that I haven't managed to articulate there?
No, look, Joseph, I think you've captured that incredibly accurately. And I think there's a continuum here, right, of how we think about data and the critical thinking approach that we take to data. So if we look at the research, if we look at the first wave of open source that came out of universities and was research driven, there were no data structures, there were no ways of handling voice data. And so it was by necessity ad hoc. And then we've gone into the massive explosion of machine learning and neural networks, where we're starting to think about data at scale, but yet we don't have a nuanced understanding of that data. We keep thinking that more data is better, that bigger data is what we want. Whereas in this third wave, I think we're going, as you said, becoming much more deliberate about data. We're thinking about the provenance of data. We're thinking about the licensing of that data. We're thinking about the way that metadata is applied to those data sets so that we can understand the limits of consent for using those data. Where can that data be used and where can it not be used? So I think you've captured that very accurately.
I really like this sort of small data, big data, deliberate data as a three-stage model, and that sort of reflects things we're seeing outside of voice as well. Okay, we're going to have to stop there. Kathy, thank you very much for this. I particularly appreciate you getting up at like before dawn. I think I can sort of see something light out of your window, just starting maybe.
We're almost at dawn. You know, this is the dawn of the third wave of open source voice. You know, there's a metaphor here.
We'll run with the metaphor. I really appreciate you doing this. It made more sense when we were like, let's have a brown bag and everyone can sit around over lunch in Mountain View and watch this talk. And it seemed like a good idea at the time. Thank you all for watching. We'll continue to have this discussion in so many ways. Please feel free to reach out to me or to Kathy through the venues that you see on the screen. And have a good day, everybody. Thanks very much. Bye-bye.
Thanks, everyone. Stay well.